Okay, move forward. Here we go. I know it's going to look like this. Y equals A sine K theta plus C plus H. Remember, it's going to look like this. Agreed? Mr. Pugh, you with me? Nope. Well, you better should be, because this is what it's going to look like when I'm done. All I need is A, K, C, and H. So, I read the problem. The problem says, I have waves that start at the maximum, go down to the minimum, go back to the maximum every how long? 10 seconds. 10 seconds. So this is 10 seconds right here. It says that the height of this is 3 meters. I assume this is 0. This is down 3 meters. Agreed? It looks like a cosine graph, but since I said sinusoidal, you're going to have to use a sine graph. Now, if I didn't tell you, which way would you probably go? Cosine, right? This begs. Let's do cosine. Why do sine? Tough. I said sinusoidal. I made you put it in there. So because I did that, you're going to have to do this graph. So what do I do? I'm going to start going y equals. So the first thing I'm going to notice is what? What's my amplitude of this wave? 3. Trick, watch out. If it goes from like 1 to 7, that's only 3 as well, right? Because it's going from 3 to negative 3, right? So the total this is a 6, but the amplitude is only a 3, right? So then I go sine. Hey, I need a K. Well, period equals 2 pi over K. Agreed? What is the period of this wave? 10. So 10 equals 2 pi over K. We use our trick. I'm going to move my K over here. K over here. Any chance K is 0? No, that's just silly talk. So then 10K equals 2 pi. How do I solve this? Divide by 10. And I get K equals pi over 5. Agreed? So I'm going to put pi over 5 right here for K times. Now, in this case, we're talking about time, not angle, right? So it's going to become traditional for me to switch theta and turn it into a T. Not strictly speaking necessary. We're just changing the letter of a variable. Plus, and we're going to temporarily table the what's C? Let's hold off a moment on C, because C is making me nervous. And then plus, what is the height? What is the middle of this graph raised to? 0. So there's a big plus 0 here, which is a waste of time. We'll drop that in a moment. I need C. Now, there is 2 ways to do this. One of them is to try to do what he did, in which case you're going to get it wrong. He recognized what the phase shift's supposed to be. It's about pi over 2. But he forgot that there's a whole C over K portion of the program you have to deal with. And even if you do that, it gets really confusing. So here's what's going to happen. If I care what C is, I care about where we start, right? The graph? So I have to give you some point. What's one point you for sure know, Mr. Welko, is on this graph? 0, 3, because I had to give it to you at the very beginning. It's at the highest point. So I have the point 0, 3. So how are we going to solve for what C is? Remember way back when we actually solved what the y-intercept is? We actually put x and y in, didn't we? I'm going to plug in 0. I should get 3, right? Let's do it. So I plug in this equation. I'm going to solve for what C is. Yeah. So I plug a 3 in here. I get 3 is equal to 3 sine pi over 5. What's my t? 0. At time equals 0, I expect it to be 3 plus c. I'm going to drop the plus 0 at the end. Is that okay with everybody? All right. Now I'm just going to solve this thing for c. Right? So step 1, I peel off the 3 here. How do I get rid of that 3? It's 3 times sine, so I divide both sides by 3. 1 equals sine. What is pi over 5 plus 0? Times 0, sorry. 0. Simplifying further, I get 1 equals sine of c, right? 0 plus c is c. What does sine give me 1? 90 degrees. We wouldn't call it 90 degrees. We'd call it what? Pi over 2, right? So since sine is pi over 2, c is equal to pi over 2. Agreed? Where does sine give me 1? At pi over 2. Therefore, c must be pi over 2. Another way to look at it is we arc sine 1. What's the arc sine of 1? Pi over 2. Oh, yeah. So what's my final answer? What's my final model? It's going to make it look like this when I'm done. Y equals 3 sine pi over 5 times t plus pi over 2. That's my final model. Did you what?
You said that I got it wrong.
How'd you get it wrong?
Like you said, if you did the thing that I did, you get it wrong.
Oh, you get pi over 2. Huh. Lucky dog. That's lucky. Yes.
So I did it differently.
How'd you do it differently?
I looked at how much of the wave I wanted to.
Don't do that. Don't do that. Dangerous. Dangerous. Very dangerous. Because of the power point, this would have to work out because it's a 0 point, but I might give you 1 and something else. Much better off just plug in a point. Just a general. I'm a little bit worried about why that worked out on this one, but that's discussion for another day. All right, so then it says, so that's my model, right? So 5 seconds after this thing starts, Miss Kirkland, what's its value? Plug 5 in there. So let's plug in 5 and see what you get. Pi over 5 times 5 plus pi over 2. I'm solving this, right? Miss Kirkland, what is 5 pi over 5? Just 1 pi, right? So pi plus pi over 2. What's pi plus pi over 2? No. If I need a common denominator, I have to put a 2 on top and bottom, right? So it'd be 3 pi over 2, right? 3/2 pi. Pi and a half. What is sine of 3 pi over 2? No, I don't want you to be anywhere near degrees. You should be in radians land. Although, for this one, you could probably figure it out just by simply looking at the graph. This becomes -1, right? Because here's pi, here's 2 pi, so pi and a half would be -1. Hold on, -1 for sine 3 pi or 2. I understand. I'm totally with you. You with me? Okay. So this becomes y equals 3 times -1, which is y equals -3. Does that make sense? At 5 feet, is it really -3? Yeah, if this is 10, that's halfway. That should be -3. Should give us that, right? All right, so I got this. Go ahead and do number 7.5. Do 7.5 seconds. So you're going to check your answer just by looking at the graph. Because I want to know what sine of 3 pi over 2 is. Right? And we know that pi is here. 2 pi is here, so 1/2 pi is here, so that would be -1. So I put a -1 in here. 3 times -1 is -3. Now, could you put in your calculator? Yeah, sine of 3 pi over 2 is -1 times 3 is -3. You'll do it too, as long as you're in radians. How are we doing? Okay, so we're going to put 7.5 in that equation, right? So just plug in, instead of 5, we're going to plug in 7.5. Plug it in. Nothing else, grind it up in your calculator. It'll do it for you. I'm going to stop the recording because there's not much going on here. Whee!